something called SMP that was in some ways a forerunner of Mathematica. And at the core of SMP was a computer language. And what I'd done to design that language was somehow to try to think about all the computations that people might want to do, and then to try and identify primitives that could be strung together to build up those computations. Well, that had worked fairly well, and in fact, in a much evolved form, I think it's now worked out extremely well in Mathematica. But anyway, back in 1981, I had the idea that perhaps just as I'd been able to find primitives for computations people might want to do, I might somehow be able to find primitives for what nature does as well. And the crucial thing I realized is that those primitives don't have to be based only on traditional mathematical constructs. I mean, if one's going to be able to do theoretical science at all, one has to assume that nature follows some kind of definite rules. But why should those rules involve only the kinds of constructs that have been invented in human mathematics, numbers, exponentials, calculus, and so on? Can't the rules somehow be more general? Well, in the past, there wouldn't really have been any systematic way to think about such things. But now we have computers whose programs, in effect, implement arbitrarily general rules. And the idea I had was that perhaps the kinds of rules that can be embodied in programs might actually be what nature is using. But what sorts of programs might be relevant? Well, from knowing about mathematical kinds of things, I'd assumed they'd have to be at least somewhat complicated. But still, I figured I should at least start by looking at really simple programs. I mean, in practical computing, we're used to fairly long and complicated programs that are specifically set up for particular tasks. But what I wanted to know about were really simple, short programs, say just chosen at random. What do programs like that do?